So theorem 1 or 1126 is integration of vector valued functions. And so we take the integral of r of t dt, and this is equal to the vector with the integral of component f of t with respect to t, comma, integral g of t with respect to t, comma, integral h of t with respect to t. And so when I integrate this, I get capital F of t plus c, comma, and I guess I could call this c1 because we're going to have multiple constants of integration here, comma, capital G of t plus c2, comma, capital H of t plus c3. Now, one thing that is going to happen is we're going to take care of this c1, c2, and c3 by making this vector f of t, comma, g of t, comma, h of t plus a vector c, where c is equal to c1 plus c2 plus c3. So using vector addition properties there to break that c out. Okay. Now, that's an indefinite integral. If it were a definite integral, we would have the definite integral from a to b, r prime of t dt. So if I integrate the derivative, I get back that original r of t. But I'm going to evaluate it r of b minus r of a. Fundamental theorem of calculus right there. Okay, so that f of b minus f of a from calculus 1 that you learned a long time ago is popping its head back again. So in the same way with derivatives, where we just take the derivative of each component, now to integrate, we integrate each component. So let's take an example here of an initial value problem. An initial value problem, otherwise abbreviated IVP. Okay. And they're going to give you information. So here I'm going to give you the second derivative is 2 cosine t 12t. Okay. And I want to find r of t when the following is true. When r of 0 is equal to, what do we want r of 0 to be? We want r of 0 to be -7, -1, 2. So that's an initial condition. And r prime of 0, we want that to be 5, 3, 0. Okay? So we're looking for r of t, and they tell us r double prime. So to get back to r of t, we're going to need to integrate r double prime to get to r prime. Use the initial value conditions to get the correct c for r prime. Once we do that, then we're going to have to integrate r prime plus our c to get back to r. And then we use the initial conditions to get the r of t that we're looking for. So let's work through this. So first, let's integrate r double prime. So integrate r prime of t dt. We get, what is the integral here? The integral of 2 cosine t 12t with respect to t is equal to 2t plus c1, comma, integral of cosine is sine plus c2, comma, man, I always run out of room here. Okay, let's try this. Okay, that's fine. And then the integral of 12t, add 1 to the exponent, t squared divided by 2 gives me 6t squared plus c3. Okay? So if I pull out that constant, I'm going to have, or take out to make a constant vector from his, I'm going to have 2t, comma, sine of t, comma, 6t squared plus a c vector. Okay? And what do I want this thing to equal? What do I want it to equal? Well, when r prime of, we plug a 0 in, we want it to equal 5, 3, 0. So this is r prime of t, yeah? So I want r prime of 0. This is going to be 0, comma, 0, comma, 0 plus c. And r prime of 0, we are told that r prime of 0 is equal to 5, 3, 0. So if I have the 0 vector plus c, then that means that c is going to equal this vector right here. That was pretty easy. Okay. So that tells me r prime of t is 2t, comma, sine of t, comma, 6t squared plus 5, 3, 0. Okay. Now, I can combine this back into 1 if I want to be 2t plus 5, comma, sine t plus 3, comma, 6t squared. Okay. And now I'm going to do the next step where I integrate r prime. So if I integrate r prime of t dt, this is the integral of 2t plus 5 plus sine t plus 3, 6t squared dt. And when I integrate this, I get t squared plus 5t, comma, integral of sine is negative cosine t plus 3t, comma, integral of that t cubed divided by 3, so that's 2t cubed, okay, plus my c. Again, I need to figure out what the c is, because this isn't quite the answer. Initial value problem, they give us initial values. What do they give us? They tell us that r of 0 is equal to, what do they say? R of 0 equals, r of 0 is this thing right here that is negative 7, comma, negative 1, comma, 2. Okay, so if I plug in 0, I get 0 plus 0, okay. Cosine of 0 is 1, so that's negative 1 plus 0, and then 0. Okay, plus c. So I have 0, comma, negative 1, comma, 0 plus c. So what does c equal? Well, to get c by itself, I can subtract this from both sides. Okay, and whenever I subtract this, I get c equals what? Okay, the negative distributes in, so it's actually 0 plus 1, 0. So that's going to be -7, and then -1 and 1 make 0 and 2. So that is my C. So the answer is this thing plus C, so I need to write that out. So R of t is equal to t squared plus 5t. And then if I want to just go ahead and put the 7 in here, well, maybe I'll just do that in one last step. If you want to go ahead and do that in your notes, that's great. Hate to skip too many steps. Okay, plus -7, 0, 2. And so final answer, t squared plus 5t minus 7, comma, negative cosine t plus 3t plus 0, don't have to put plus 0, and then 2t cubed rather, plus 2. All right, so I would take either one of these as the answer. You don't have to combine them if you want to leave them separate. But that's going to handle your initial value problem, okay? The last thing I want to talk about in 11.2 is arc length, okay? So arc length, theorem 11.2.7, arc length of a vector valued function. Okay, the arc length of a vector valued function. Let R of t be a vector valued function where R prime of t is continuous on a to b. The arc length L of the graph of R of t is L is the integral from a to b of the norm of the derivative of R of t dt. Okay, the derivative of the position function is the velocity. So if I write this another way, this is equal to the integral from a to b of the magnitude or the norm of v, the velocity function, dt. So I'm integrating, I'm adding up from a to b, the distance traveled is what I'm doing here, okay? This is the distance traveled on the arc from A to B. Kind of cool. All right, so let's see if we can calculate this. So let's just go, we'll take number 42. All right. Find the arc length on the interval. Okay, the interval goes from 0 to 2 pi. The function is R of t equals 5 cosine t, comma 3 sine t, comma 4 sine t. Whoa, so that's kind of a weird looking thing. It's probably gonna, 0 to 2 pi, this is like, it's like an ellipse if you're looking straight down onto it, but it's sine, so it's like it waves. And so we want to know how much does it wiggle on that path to do 1 revolution through. Okay. So what do we need? Well, we need the derivative. So let's go ahead and calculate the derivative first. So that's derivative cosine is negative sine, so negative 5 cosine. I'm sorry, negative sine. So t, and then derivative sine is cosine, so that's 3 cosine t, and then this is 4 cosine t. Okay? So what am I going to do? I need to find the magnitude of that vector. Okay, so magnitude, so it's the integral. So the arc length is the integral from a to b. A to b is 0 to 2 pi. And so it's the square root of each of these pieces squared. Yikes. Okay, so sine t squared plus 3 sine t squared. I'm sorry, cosine t squared plus 4 cosine t squared dt. Okay. So this is the integral from 0 to 2 pi of, okay, negative 5 squared is 25. So 25 sine squared t plus 9 cosine squared t plus 16 cosine squared t. Now, the nice thing about this, this is going to work out. This and this added together makes 25 as well. Okay, so we get 25 sine squared t plus 25 cosine squared t. And I can factor a 25 out of both of those, which is really good because, let me not jump too far. So square root 25, and this is sine squared t plus cosine squared t, which hopefully you've already figured out by now. This thing is just equal to 1. So to take the square root of 25, I get 5. Okay, 5 dt. And I can even do that without messing it up too bad. That's 5t from 0 to 2 pi. So that's r of b minus r of a, which is 5 times 2 pi minus 0 times 2 pi, which gets me 10 pi. How about that? All right, so that concludes 11.2.